Hi, I'm Renato, and I'm going to try to show a multi-agent framework. Please apologize my poor English and my nervousness. The first thing I think is it's important what is intelligence. And it's because it's not possible to see what is inside intelligence, and so it is described by its behavior. Like problem solving, learning, language, emotions. And narrow AI has addressed these problems and has done a quite good job. And is it that if we can get all of this together, we will have AGI? In my understanding, these are not these are expected outputs of intelligence, but they are not the intelligence itself. Intelligence is what makes these outputs possible. So that could be the capacity to acquire and apply knowledge. And that is going to be my goal for making agents to do that. So agent are things that perceives the environments and then acts upon it. So if we analyze in the UML sequence diagram, the first thing to notice is that agents are usually described like one thing, sensors and agents, and the decision unit. So I think in me as a object-oriented programming, we need to separate these things and describe each one separated. And then what we call agent, it's actually only its mind, the decision unit. And if you see by the diagram, we see that the only method in the agent would be the perceive method. And somehow I didn't find any multi-agent framework that has this kind of method. But in my framework, this is the only method, and all of the interactions between the agent should be with this method, including attempts of communication. But intelligent agents are things that can acquire and apply knowledge. But the agent, the mind, cannot acquire knowledge. It needs a body to do it, and a body to represent it. And then the role of the mind would be to store this knowledge and then retrieve it, and then decide what to do. So in the framework we have a very simple class diagram, and the other thing in the agent is the perceive method that was shortened to C. And extending this interface, that we have the mind that needs to set and get the knowledge. And to test this model, we did a very simple Java implementation of a null-purpose agent ready to run. We call it a naive agent. And this is an early development framework, so we're still trying what we can do with a single agent. And we are beginning tests, making them communicate with each other. So in a simple example, we can see the first thing that happens is we instantiate the agent and then try to make it we say an order for it to write, but it cannot write because it doesn't know what it is. So after we set the knowledge inside the agent head, it will be able to write it. But that is not good enough, because we should not use agents as objects. If we invoke methods, it will be like triggering, pushing a button and triggering the behavior without the agent's decision. So the agents should communicate with each other. And I think because of that, most multi-agent frameworks focus on the communications and try to define protocols and methods for it. So, but in my opinion, this is wrong because okay, the agent is not forced to execute any actions, but it's forced to communicate. And also, the communication language will be hard-coded. You can change it. So despite that, in our example, we had used the agent as an object and set the knowledge inside it. But a teacher cannot set the knowledge inside the student head. And can the teacher at least get the student's attention? So the sensors and actuators, the body of the agent, are objects that we can in fact see and manipulate it. And we think the mind is in control of the body. But has anyone seen the mind? It's not. We just suppose it exists, but it's not. We don't have a proof. So in a realistic agent-oriented world, actually the agent and the mind should not even exist. So. And in fact, that's what we are seeing this. The environment knows nothing about the agent. It can see the sensors and actuators, but it cannot see if the agent in fact exists. So, in practice, the practical application is that especially agents should not be used, and especially not built as objects. So, in other multi-agent frameworks, we start programming. And then we put the agent to life and test if it does the right thing. And if the agent fails, then we kill the agent and start programming again. And then we'll give life to a new agent. So is that how you would do with your kid? If your kid doesn't fails a math exam, you will kill him and try to make a smarter one. So. What we propose is that you should start initiating and putting an agent to life, and then after it you can try to program and teach the agent to the task you should do. And if it fails, you can just come back and program more. So we're trying to avoid the cycle of a deep refresh state, and it's like Web 2.0. You can update a single method without clearing the entire software.